Hello, today I am going to discuss with you about the basic principle of capacitors. As you know, there are many capacitors available in the market and there are many types, many forms. So today I am only concentrate on the most common and basic capacitors as shown in the circuit. This is the electrolytic capacitor. It is one of the type of polarized capacitor. Polarized capacitor is the capacitor that have the polarity like positive and negative polarity as shown here. So the positive polarity side of the capacitor will be connected to the positive side of the DC power supply. Similarly, the negative polarity of the capacitor will be connected to the negative polarity of the DC power supply. For capacitor, the charging time is extremely fast, while the discharge time is very fast. Okay, so what happens is if we close the switch, the current will flow through this component and this component, meaning the current will flow to here and then branch out into two paths. One is to flow through the capacitor, the other one will flow through the lamp. Okay, so this capacitor will be charged fully until it reach 6 volt. So the charging of the voltage depends on the DC power supply. Let's say the DC power supply is 6 volt, so this capacitor will be fully charged to 6 volt. If the DC power supply is 10 volt and the capacitor will be fully charged to 10 volt, after that it will stop charging and the current will stop flowing through this capacitor, and the current will only flow through this circuit, meaning will go through the lamp only afterward. Okay, I will demonstrate for you this basic principle operation. Now I close the circuit and then I run the circuit simulation. You can see what happened is the lamp light lit out and then the capacitor is fully charged to 6 volt. After fully charged to 6 volt, it will stop charging and the current will stop flowing through this capacitor. This current will only flow through this circuit, meaning will only flow through the lamp and then go back to the DC power supply. This lamp will light out because the current flows through it. Okay, what happened is if I open the switch, so if I open the switch, there's no current flow through the lamp. However, due to the high potential difference in the capacitor, this voltage will be discharged. The charge will be discharged through this lamp and the lamp will light out. And this discharge is very fast. I will demonstrate for you through this circuit simulation. Now I open the switch and you can see capacitor will be discharged through the lamp, and the lamp just now you see light out, then slowly fade out. Once it's fully discharged, you can see the lamp will be dim, and then after that will not light out. If we connect the multimeter or voltmeter across the capacitor, we can see the voltage charging and discharging. Okay, for example, I connect the voltage across the capacitor. Okay, I show the waveform so that you can see clearly. Okay, now I switch on the switch. I close the switch. The current will flow through the lamp as well as the capacitor. It will charge the capacitor fully to 6 volt. After that, it will stop charging and the current will stop flowing through this capacitor. The current will only flow through the lamp. Of course, the lamp will light out. After that, I will open the switch. The current will stop flowing through the lamp. However, due to the high potential difference in the capacitor, this capacitor will discharge through the lamp and the lamp will light out. After that, will slowly fade out. Okay, let's demonstrate through the circuit simulation. Now, I close the circuit switch. You can see You can see the voltage here, fully charged up to 6 volt. This shows that the capacitor voltage measured by the voltmeter here. After fully charged to 6 volt, you can see here, the capacitor will stop charging. What happens if I open the switch? You see the capacitor voltage will quickly discharge. After finish discharging, the lamp will not light out. So that's it. Thank you.